Hi, welcome to video 1.5b. This is the last video from chapter 1. This is more infinite limits. Okay, so again, I want to talk about justifying vertical asymptotes now. Finding them is easy. You've been able to do that forever. Obviously, the vertical asymptote here is x equals 2. But justifying it in calculus means you've got to use the infinite limits. So you know from Algebra 2 and Pre-Calc, if you have a rational function, the vertical asymptote occurs for denominator factors that do not also occur in the numerator, because if they do, then you have a point discontinuity, right? Okay. Now, what's going to happen is you're easily going to be able to identify for me or the AP reader what the equation of the vertical asymptote is. And let me just emphasize, if I ask you for the equation of the vertical asymptote and you write 2, I'm sorry, 2 is not the equation of a line. It's x equals 2. Okay, so if you're going to justify it, and here's the key thing, you don't have to do both. If all I'm asking you is what's the equation of the vertical asymptote and justify, and I don't ask you to graph, then you can either show me that the limit as x approaches that number 2 from the left of f of x, or the limit as x approaches that number 2 from the right of f of x equals infinity or negative infinity. So in this particular case, if I plug in 2, I get 5 over 0. 5 is positive. Approach 2 from the left, 1.9. 1.9 minus 2 will give me a 0 through negative. So that's going to be negative infinity. Somebody else might decide to approach 2 from the right. Again, if they plug in 2, they'll get 5 over 0. 5 is positive. They're plugging in 2.1. 2.1 minus 2 is positive. So the denominator approaches 0 through positives. Positive over positive gives positive infinity. Now, if I ask you to graph it, first of all, I will give you, although you should know the horizontal asymptote is y equals 1. But right now, I would give you that. Certainly, it's very easy to find the y-intercept. Replace x by 0, you get negative 3 halves. And finding the x-intercept, a little harder, but not that much harder. Replace y by 0, and obviously, the only time a fraction is 0 is when the numerator is 0. So you have this one y-intercept, this one x-intercept. You have a vertical asymptote of 2, a horizontal asymptote of y equals 1. If you actually find both of these limits, then you will know that on the left side of the vertical asymptote, it heads down to negative infinity, but on the right side, it heads up. And by joining those points, you now are easily able to graph this. Okay? Now, a graph will never cross its own vertical asymptote because the denominator can never be 0, but it is possible for a graph to cross its own horizontal asymptote. For example, a graph can do this. And the reason is because a horizontal asymptote is the behavior of the graph at the far right, far left end, not somewhere in the middle. So you should always ask yourself, does it cross the horizontal asymptote? Now, our horizontal asymptote is y equals 1, so simply take the function, replace y by 1, and try and solve. Most times you'll find out that it doesn't work and that the answer is no, it does not cross it. Okay, so if you look at the textbook at this point, and you're looking at numbers 14, all it says is find the vertical asymptotes, if any. So you're looking at 13 through all the way to 32. But it does not say that it wants you to justify or graph. So this you've been able to do for 2 years now. Vertical asymptote here is whatever makes the denominator 0 as long as that factor doesn't occur in the numerator. So the vertical asymptote is x equals 2. Remember, if you tell me it's 2, that's nonsense. I got to take off points. Here, the denominator cannot be factored. It will always be positive. There are no vertical asymptotes. Here, it factors into x plus 5, x minus 5, vertical asymptotes, actually 2 of them. Make sure you check against the numerator to make sure you don't have a point discontinuity. Okay, so, again, if you have a limit of a fraction and substitution yields non-zero over 0, you're going to get either infinity or negative infinity, okay? Again, I prefer not to have an answer of does not exist. These are much more descriptive answers, okay? So I think we talked about this one already anyways. There's something very similar to it. You can easily tell the vertical asymptote is at x equals 2. If you're asked to justify, you can do either of these from the right or from the left. But if I ask you the graph, then you will need to do both. So from the right, again, if you plug in 2, you'll get 3 over 0, non-zero over 0. We know it's going to be infinity or negative infinity. Approach 2 from the right is 2.01. Minus 2 will give 0 through positives. 3 is positive, positive over positive. Here, replace x by 1.9. This will give a negative, and so you'll get negative infinity. Okay? Again, the most important step is this one right here, where I see positive over 0 through negative. Number 6, looking at the directions now over here for number 6, it says determine whether f of x approaches infinity or negative infinity as x approaches negative 2 from the left and from the right. So you can see that from the left, as you approach negative 2 from the left, you're going down to negative infinity. As you approach negative 2 from the right, you're going up to positive infinity. Okay, number 8, again, they're just interested at negative 2. From the left at negative 2, you're going down to negative infinity. From the right at negative 2, you're going up to positive infinity. So that's just a question. Now, not that they're asking from the right side, from two sides, but obviously they both don't exist, which means the answer doesn't exist. But more importantly, they're approaching two very different things. Now, here's where you're going to have to be very super duper careful about this square. Because what's going to happen is, if I substitute 2, I'll get negative 3 over 2 minus 2 is 0 squared is 0. So I know I have a non-zero over 0. I know I'm going to get infinity or negative infinity. Now the numerator is negative 3. The denominator is approaching 0 through something. Now if I approach 2 from the left, think 1.9. 1.9 minus 2 is negative, but you're squaring it. So you're going to force it to be positive because you're squaring a negative. So a negative divided by a positive will give negative infinity. Here's another situation. Let's say there's a binomial. There's two binomial factors in your denominator. If I was to plug in 2, by the way, I would get negative 3 over negative 1 times 0, which would be negative 3 over 0. So I know I'm going to get infinity or negative infinity. Now here, I can actually plug 2 into here, and 2 minus 3 is negative 1, and I need that negative. But here, this is the culprit, this is the problem, this is what causes a denominator of 0. So if I think of 1.9 here, 1.9 minus 2 will approach 0 through negatives, and then I am cubing that. Well, when you cube a negative, you get a negative, and you now have 3 negatives multiplied and divided, which will give a negative. So here's a few more examples. Again, looking at the directions for 26, etc. Still, the directions here are just find the equations of the determine. Right here, find the vertical asymptotes, if any. That is all they're asking, is to just find the vertical asymptotes. So you're going to factor the denominator. There's 4 terms. You're going to factor it in sections. Be very careful. There is, if you factor the numerator, this is a common factor. It does not produce a vertical asymptote. It produces a point discontinuity. And this factor, of course, never equals 0. So there are no vertical asymptotes. Here, of course, we're back to trig again. You should know that secant is 1 over cosine, so it won't exist at all the odd pi's over 2. However, what we have is pi x, so the angle pi x cannot equal 2k plus 1 times pi over 2, and therefore the pi will end up over here. So again, where k is any integer. Here's another one. If you do substitute, you will get a non-zero over 0. It might take you a while to figure that out. At any rate, you're going to factor. So I factor the numerator, factor the denominator. Notice there's no common factors in the numerator and denominator, so there's no point discontinuity. So I will have a vertical asymptote at negative 2 and at 3. Now, if I look, the limit as x approaches 3 from the left, okay, and that's the question, limit as x approaches 3 from the left. So I already know that when I plug 3 into here, I get 4 times negative 1, which is negative 4, over 5 times 0 is 0. So I already know the numerator is negative. The denominator, though, this factor doesn't go to 0 when I plug in 3. That's just positive 5. But this is the factor that goes to 0. If I approach 2 from the left, 2.9 minus 3 is negative. So I have a negative over a positive times a negative. That's going to give me a positive infinity answer. And that's the end of video 1.5b.